Here I am working problem 1.2 in the end of chapter 1. And it says a vector A extends from the origin to point 1 dash comma 2 comma 3, and vector B extends from the origin to 2 comma 3 comma minus 2. And they ask, find the unit vector in the direction of A minus B. So A minus B is going to be equal to, well, we have point A, that's 1, minus point B is 2, and that's in that AX, plus, and then AY is going to be 2, that's point A, minus 3, AY, and then we have point A again, which is 3, minus point B, which is a minus 2 AZ. And so that equals minus AX minus AY and plus 5 AZ. But they want to know the unit vector in that direction, so we need some unit vector, which is going to be A minus B over the magnitude of A minus B. And so the magnitude of A minus B, the magnitude of A minus B is going to be equal to the square root of the coefficients squared, so minus 1 squared plus 5 squared. And so that means A minus B is going to be equal to, what's that, 25, 26, 27. Square root of 27, which is equal to the square root of 3 times 9, which is equal to 3 times the square root of 3. So that's the magnitude. So now we can plug that in here. We know what A minus B is. We calculated it, so that's minus AX minus AY plus 5AZ divided by the magnitude, which is 3 times the square root of 3. So that's the answer. That's the unit vector in the direction of A minus B. So we can put a little line here saying that's our answer. And then the next part, they say they want us to find the unit vector in the direction of the line extending from the origin to the midpoint of the line joining the ends of the A vector and the B vector, A and B. So that's just going to, they want the midpoint, so we have some like point A and a point B, and there's a line, and here's the origin, so they want this line from the origin to the midpoint. And so this is just going to be equal to 1/2 of A plus B is going to be that line, and then we're just going to have to divide that by to get the unit vector, just going to have to divide it by the magnitude of 1/2 A plus B. And so 1/2 of a plus b. So a is equal to 1 plus 2. That's ax. And then we're going to have 2 plus 3 ay plus, the last point is we're just taking a plus b by the components 3 minus 2 az. And so that's going to equal, so this is just a plus b. A plus b is equal to a plus b. So that's going to be 3 over 2 ax plus, we got 2 plus 3 is 5, divided by 2 is 5 over 2 ay. Ay. And this is going to be 1, so plus 1/2 az. And then we have to do the magnitude of, okay, I should say this is 1/2 a plus b. So the magnitude of 1/2 a plus b is going to be equal to all that squared, the square root of the coefficient squared. So 3 divided by 2, 5 over 2, and plus 1/2 squared. So that's going to equal, see, that's 9 plus 25 plus 1. So that's 10 plus 25. So that's going to be the square root of 35 over 4, which equals the square root of 35 over 2. And so if we put this all together, we're going to have, you know, the 1/2, the a plus b, because we're wanting the direction, okay, so that's just going to be a unit vector, over the magnitude of 1/2 a plus b. So we're going to have basically 2 times, where to go, 3 over 2 ax plus 5 over 2 ay and plus 1/2 az, all over the square root of 35. Because I've already inverted it here. So that just leaves you with, we draw a line here, 3ax plus 5ay plus az over the square root of 35. So that's your answer right here. That's going to be the unit vector. And that's what they wanted, the unit vector in the direction of the line. And that's all there is for that problem.